Now in this lecture we'll find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC equals to 30 degrees. This angle ACB equals to 100 degrees. And we also know that side AD equals to side BC. And we want to find out the value of this angle ADC. So we start with the first method. In the first method, first of all, we will define side AC of triangle ABC as A, that is to say the length of AC equals to A units, and we will define side BC of triangle ABC as B, that is to say the length of side BC equals to B units. BC equals to B units. And in the next step, and we also know that AD equals to BC. AD equals to BC according to what is given us in the question. But BC equals to B units according to our definition. So from this equation, we will derive that AD also equals to B units. AD equals to B units. So here AD equals to B units. In the next step, I will present to you a new law that is actually the law of sines. The law of sines is true in any triangle. So we can write down that in any triangle, so if we have a triangle ABC, that could be any triangle. This is triangle ABC. And we know that the length of side BC of triangle ABC equals to A units. This angle is angle A. The length of side AC of triangle ABC equals to B units. And this is angle B. And the length of side AB of triangle ABC equals to C units. And this is angle C. Then, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. So I repeat again, in any triangle, A over sine A equals to B over sine B equals to C over sine C. From this formula we will derive that A over sine A equals to B over sine B. And we will implement the law of sines in triangle ABC. So I will copy this triangle ABC in a new page, and we will implement the law of sines in this triangle ABC. So this is triangle ABC that I copied from the original drawing. You know that angle ABC equals to 30 degrees, angle ACB equals to 100 degrees, AC equals to A units, and BC equals to B units. And we will find out the value of angle CAB. This angle, we will define it as angle X, and we know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABC, we will get that X plus 30 degrees plus 100 degrees must be equal to 180 degrees. Here we will subtract 130 degrees from this equation, and we will get that X equals to 180 degrees minus 130 degrees. That is to say, X equals to 50 degrees. So we found out that angle X equals to 50 degrees. So I will substitute angle X by 50 degrees. And now we will implement the law of sines in this triangle, triangle ABC. Here we will get that A over sine 30 degrees equals to B over sine 50 degrees. So here we will divide equation number 1 by B, and then we will multiply it by sine 30 degrees, and we will get that A over B equals to sine 30 degrees over sine 50 degrees. I'll repeat again. According to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Okay, so in the next step, I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle, triangle ADC. But first of all, we have already found out that angle BAC, this angle equals to 50 degrees. So if angle BAD equals to theta, then angle DAC must be equal to 50 degrees minus theta, because of the fact that the sum of those two angles equals to 50 degrees. Okay, and we will define angle ADC, the angle that we are looking for is angle Y. And we know that the sum of the angles in any triangle, and especially in triangle ADC, must be equal to 180 degrees. That is to say, Y plus 100 degrees plus this angle that is 50 degrees minus theta must be equal to 180 degrees. Here we will subtract 150 degrees from this equation, and we will get that Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add angle theta to this equation, and we will get that angle Y equals to 30 degrees plus theta. So we found out that the angle that we are looking for, that is to say angle ADC, equals to 30 degrees plus theta. So I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle, triangle ADC. So this is triangle ADC that I copied from the original drawing. Here we know that AC equals to A, and we also know that AD equals to B. Angle DAC equals to 50 degrees minus theta. Angle ACD equals to 100 degrees. It is given us in the question. And we found out that the angle that we are looking for, that is actually angle ADC equals to 30 degrees plus theta. And according to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. So here we will divide equation number 2 by B, and then we will multiply it by sine 30 degrees plus theta, and we will get that according to equation number 2, A over B equals to sinus 30 degrees plus theta over 100 over sinus, here it is actually sinus 100 degrees. I'll repeat again. We implemented the law of sines in this triangle ADC, so we got that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Here it is B over sinus 100 degrees. And then we divided this equation number 2 by D, and then we multiplied by sine 30 degrees plus theta. So we got that A over B equals to sine 30 degrees plus theta over sine 100 degrees. And according to equation number 1, we have already found out that A over B equals to sine 30 degrees over sine 50 degrees. And we will create equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay, so, and we will get that A over B according to equation number 1, it is actually sinus 30 degrees over sinus 50 degrees. And it must be equal to A over B according to equation number 2. And A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. So I will repeat again on equation number 3. According to equation number 3, A over B according to equation number 1 equals to A over B according to equation number 2. Here we will cross multiply equation number 3, and we will get that here sinus 30 degrees is 1 over 2. So it is 1 over 2 times sine 100 degrees. That equals to sine 30 degrees plus theta times sine 50 degrees. Here we will use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. So we will use this trigonometric identity for sine 100 degrees. According to this trigonometric identity, the value of sine 100 degrees will be equal to 2 sine 50 degrees times cosine 50 degrees, and it equals to sine 30 degrees plus theta times sine 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled. And we have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And we left only with cosine 50 degrees that equals to sine 30 degrees plus theta Here we will use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. And so we can substitute cosine 50 degrees in this equation, equation number 3, by sine 40 degrees. So we'll do it and we will get that sine 40 degrees equals to sine 30 degrees plus theta. Sine 40 degrees equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we'll subtract 30 degrees from this equation, equation number 3, and we will get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees. And the angle that we are looking for equals to 30 degrees plus theta. 30 degrees plus theta is 30 degrees plus 10 degrees. That is to say, angle ADC, the angle that we are looking for, equals to 40 degrees. Okay, angle ADC equals to 40 degrees, and that is the answer to our question, that the value of angle ADC is equal to 40 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of this angle ADC according to the second method. In the second method, we will define side BC of triangle ABC as A. That is to say, the length of side BC is equal actually to A units. BC equals to A. And according to our what is given us in the question, we know that BC equals to AD, and according to our definition, BC equals to A units. So from this equation, A equals to BC equals to AD, we will derive that AD also equals to A. So we can write here that AD equals to A. In the next step, we will extend side BC of triangle ABC by a straight line. And from point A, we will draw perpendicular to the extended BC. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the intersection point between the extended BC and the point and the perpendicular from point A as point E. We will define side AE as Y, and we will define line segment CE as X. In the next step, we will focus on the right triangle AC. On the right triangle AC, we know that first of all, we'll find out the value of this angle. So we define angle ACE as angle Y. And we know that the sum of the angles, we know that BC is one side of triangle ABC, therefore BC must be a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that still must be a straight line. So we can write down that line segment BE is a straight line. and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE, it's point C, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus the size of angle Y must be equal to 180 degrees. Again, here the sum of the angles on the upper side of the straight line BE at point C must be equal to 180 degrees. That is to say, 100 degrees plus the size of angle Y must be equal to 180 degrees. Here we subtract 100 degrees from this equation, and we get that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that the value of angle Y, this angle ACE equals to 80 degrees. So in the next step we will focus on the right triangle ACE. On the right triangle ACE, tangents 80 degrees, equals to AE over EC. I will repeat again. On the right triangle ACE, tangents 80 degrees equals to AE over EC, but AE equals to Y according to our definition, and EC also equals to X according to our definition. So in conclusion, we found out that tangents 80 degrees equals to Y over X, so here we will multiply equation number 1 by X, and we will get that Y equals to X tangents 80 degrees. So according to equation number 1, Y equals to X tangents 80 degrees. In the next step, we will focus on the right triangle ADE. On the right triangle ADE, we know that first of all we will define angle ADE. The angle that we are looking for is angle theta. So in the right triangle ADE, we will get that sinus theta equals to AE over AD. I repeat again, in the right triangle ADE, we will get that sinus theta equals to AE over AD. Here, AE equals to y according to our definition, and AD also equals to y according to our definition. So actually we found out that according to equation number 2, sinus theta equals to y over a. I repeat again. According to equation number 2, sinus theta equals to y over a. Here we will divide equation number 2 by a, and then we will multiply equation number 2 by a, and then we will divide it by sinus theta, and we will get that a equals to, according to equation number 2, a equals to y over sinus theta but according to equation number 1, y equals to x times 80 degrees, so we will substitute y in equation number 2 by x times 80 degrees, and we will get that a, according to equation number 2, equals to y, that is x times 80 degrees, over sinus theta. Again, according to equation number 2, a equals to x times 80 degrees over sinus theta, and according to equation number 1, y equals to x times 80 degrees. In the next step, we will focus on the right triangle ABE. On the right triangle ABE. Tangents 30 degrees. Equals to AE over BE. I repeat again. On the right triangle ABE, tangents 30 degrees equals to AE over BE. But according to our definition, AE equals to y, and BE equals to a plus x. So in conclusion, we actually got the tangents 30 degrees equals to y over a plus x. Again, according to equation number 3, tangents 80 degrees equals to y over a plus x. So here we will substitute y and a in equation number 3 by the values for y and a that we found in equations number 1 and equation number 2. Okay, so and we will get that tangents 30 degrees according to equation number 3, tangents 30 degrees equals to y according to equation number 1 is x times tangents 80 degrees over a plus x. A, according to equation number 2, a is x tangents 80 degrees over sinus theta, which is a plus x. Here we will multiply x by sinus theta and then we will divide it by sinus theta in order to overcome a factor with this expression. So we change nothing, therefore it is allowable. Here we will move sinus theta from the denominator to the numerator and we will get that tangent 30 degrees equals to x times tangent 80 degrees times sinus theta over x times tangent 80 degrees plus x times sinus theta. Here we have x in the numerator and we have x also in the denominator, so x will get cancelled. And we also know that tangent 30 degrees is equal to 1 over square root of 3 units, so I write it down according to equation number 3. We will get that tangent 30 degrees is 1 over square root of 3 units. That equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta So I'll repeat again. Going to equation number 3, we got that one over square root of 3 units, it is actually tangent 20 degrees, equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we will cross multiply equation number 3 and we get that according to equation number 3, tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta So here we will subtract sinus theta from this equation, equation number 3, and we will get that tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta Here we will take sinus theta as a common factor out of this side of equation number 3 and we will get the tangent 80 degrees equals to sinus theta is a common factor Inside the brackets from this expression we will get square root of 3 times tangent 80 degrees. And from sinus theta, what is left after we took sinus theta is a common factor. What is left, it is actually minus 1. Here we will divide this equation number 3, by square root tangent 80 degrees minus 1, and we will get that sinus theta equals to tangent 80 degrees sinus theta equals to tangent 80 degrees over square root of 3 tangent 80 degrees minus 1 we know that tangent 80 degrees is sinus 80 degrees over cosinus 80 degrees, so we'll substitute tangent 80 degrees in equation number 3 by sinus 80 degrees minus cosine 80 degrees. We'll do it now and we'll get that sinus theta equals to tangent 80 degrees is sinus 80 degrees over cosinus 80 degrees over square root of 3, and tangent 80 degrees is sinus 80 degrees over cosinus 80 degrees and we have also minus 1, so we will multiply minus 1 by minus cosine 80 degrees and then we will divide it by cosine 80 degrees in order to have a common factor with this expression. So here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And we will get that sinus theta equals to sinus 80 degrees over square root of 3 sinus 80 degrees and it is actually sinus 80 degrees over square root of 3 sinus 80 degrees minus cosinus 80 degrees. So here we will multiply the denominator by 2 and then we will divide it by 2 and we will get that sinus theta equals to sinus 80 degrees over, we multiply the numerator by 2 and then we divide it by 2. One over 2 is sinus 30 degrees, so we substitute here we will divide cosine 80 degrees by 2. And here we multiply it by 2, so we change nothing. According to equation number 3, sinus theta equals to sinus 80 degrees over 2, and inside the brackets we have square root. First of all, it is sinus 80 degrees, and square root of 3 over 2 is equal to cosine 30 degrees, so we substitute square root of 3 over 2 by cosine 30 degrees. And we substitute 1 over 2 by sine 30 degrees. So we actually got that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times, here sinus 80 degrees times cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sinus A times cosine B minus sinus B times cosine A equals to sine A minus B. So according to this trigonometric identity, we will get that we can substitute our expression by sine A minus B, when A equals to 80 degrees and B equals to 30 degrees. So we will do it now, and we will get that our expression will be equal to sinus A minus B. A is 80 degrees and B is 30 degrees. So our expression equals to sine 80 degrees minus 30 degrees. Okay, and we will get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees minus 30 degrees is 50 degrees. Okay. We will use the trigonometric identity that sinus 2a equals to 2 sine a cosine a and according to this trigonometric identity we will get that sinus 80 degrees equals to 2 sinus 40 degrees times cosinus 40 degrees all divided by 2 sine 50 degrees. Here we will use the trigonometric identity that states that sinus alpha equals to cosinus 90 degrees minus alpha, and according to this trigonometric identity we will get that sinus 50 degrees equals to cosine 90 degrees minus alpha is 50 degrees, it is actually 90 degrees minus 50 degrees. So we actually found out that sinus 50 degrees, according to this trigonometric identity, sinus 50 degrees equals to cosine 90 degrees minus 50 degrees is cosine 40 degrees. So we found out that sinus 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sinus 50 degrees in this equation, equation number 3, by cosine 40 degrees. And we will do it and we will get that according to equation number 3, sinus theta equals to 2 sinus 40 degrees cosinus 40 degrees divided by 2 sine 50 degrees, and according to this equation sine 50 degrees equals to cosine 40 degrees, so we'll substitute sine 50 degrees in this equation, equation number 3, by cosine 40 degrees, which will be 2 times cosine 40 degrees. So here we have cosine 40 degrees in the numerator and we have cosine 40 degrees in the denominator. So cosine 40 degrees will get cancelled. 2 over 2 is 1, so 2 also will get cancelled. And we left only with sine theta that equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees. So the angle that we are looking for, that is actually angle ADC that equals to theta equals to 40 degrees. So angle ADC that equals to theta, it is actually equals to 40 degrees. And this is the final answer to the question, that the angle that we are looking for, that is actually angle theta, equals to 40 degrees. we finished with the second method. In the next step, I will summarize the lecture. Actually, we found the value of angle ADC in two different methods. In the first method, we defined side AC of triangle ABC as A, and we defined side BC as B, and we have it is given us in the question that AD equals to BC from one side, but from the other side, according to our definition, BC equals to B units. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B, so we can write here that AD equals to B. Then I presented to you the law of sines. According to the law of sines, in any triangle, if you know that the length of side AB equals to 3 units, the length of side AC equals to B units, and the length of side ABC equals to A units, this is angle A, this is angle B, and this is angle C, then in any triangle, A over sine A equals to B over sine B equals to C over sine C. From this formula, we will derive that A over sine A equals to B over sine B, and we implemented the law of sines in our triangle ABC. So I copied this triangle ABC in a new page. This is triangle ABC from the original drawing. This angle equals to 30 degrees. This angle equals to 100 degrees. It is given us in the question. So this is the missing angle. And so in triangle ABC, here in triangle ABC, the sum of the angles must be equal to 180 degrees. So angle X plus this angle that is 100 degrees plus this angle that is 30 degrees, in total they must be equal to 180 degrees. We subtracted 130 degrees from this equation, and we found out that angle X equals to 180 degrees minus 130 degrees is 50 degrees. So we found out that this angle equals to 50 degrees. Then we implemented the law of sines in this triangle ABC. According to the law of sines, A over sinus 30 degrees equals to B over sinus 50 degrees. Okay, then we divided equation number 1 by B, and we multiplied it by sinus 30 degrees. And we got that A over B equals to sinus 30 degrees over sinus 50 degrees. This is equation number 1. Then we focused on triangle ADC. So I copied triangle ADC in the new page, and we implemented the law of sines in this triangle ADC. But first of all, we have already found out that this angle BAC equals to 50 degrees. So if this angle equals to 50 degrees, and we will define angle BAD as theta, then 50 degrees minus theta will be equal, will be the value of this angle that is actually angle DAC again. We know that angle BAC equals to 50 degrees. So if we subtract 50 degrees if we subtract theta from this big angle that is 50 degrees, we will get the value of this angle that is actually 50 degrees minus theta. So angle DAC equals to 50 degrees minus theta. This angle is 100 degrees, it is given us the question, and this angle is angle Y that we are looking for, and we know that the sum of the angles in triangle ADC must be equal to 180 degrees. That is to say, angle Y plus this angle that is actually equals to 50 degrees minus theta plus this angle that is 100 degrees. In total, they must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we found out that y minus theta equals to 180 degrees minus 150 degrees. That is to say, it equals to 30 degrees. Then we added theta to this equation, and we found out that angle y equals to 30 degrees plus theta. This angle that we are looking for, that is actually angle ADC and also angle y, equals to 30 degrees plus theta. Then I copied this triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. So actually, this is triangle ADC. We know that AC equals to A, AD equals to B, angle CAB is 50 degrees minus theta, angle ACD equals to 100 degrees. It is given us the question, and the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. Then we implemented the law of sines in triangle ADC, this triangle. According to the law of sines, A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. This is equation number 2. Then we divided this equation number 2 by B, and then we multiplied by sinus 30 degrees plus theta, and we got that A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. Okay? And according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees, and according to equation number 1, we have already found out that A over B equals to sinus theta over sinus A over B equals to sinus 30 degrees over sinus 50 degrees. So we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay? And A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. Here we cross multiply this equation number 3, and here we know that sinus 30 degrees is 1 over 2 times sinus 100 degrees will be equal to sinus 30 degrees plus theta times sinus 50 degrees. We use the trigonometric identity that states that sinus 2a equals to 2 sine a cosine a in order to treat sinus 100 degrees. So according to this trigonometric identity, sinus 100 degrees will be equal to 2 sinus 50 degrees times cosine 50 degrees. That equals to sine 30 degrees plus theta times sine 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled. We have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will also get cancelled. And we left only with cosine 50 degrees, that equals to sine 30 degrees plus theta. And according to the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, we will get that cosine 50 degrees will be equal to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute here, we will substitute cosine 50 degrees in this equation number 3 by sine 40 degrees. So we did it and we got that sine 40 degrees according to equation number 3 equals to sine 30 degrees plus alpha. If sine 40 degrees equals to sine 30 degrees plus theta, it means that 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation, equation number 3, and we got that angle theta equals to 10 degrees. So angle theta equals to 10 degrees. But the angle that we are looking for equals to 30 degrees plus theta. That is to say, the angle that we are looking for equals to 30 degrees plus theta, and theta is 10 degrees. That is to say, angle ADC that equals to 30 degrees plus theta, it is actually 30 degrees plus 10 degrees. That is to say, angle ADC equals to 40 degrees. So we found out that according to the first method, the angle that we are looking for, angle ADC, equals to 40 degrees. Then I presented to you how to find out the value of angle ADC. This angle, according to the second method. In the second method, we defined BC as A. So BC equals to A according to our definition, but according to what is given us the question, we know that BC equals to AD from one side, but from the other side BC equals to A according to our definition. From this equation that A equals to BC equals to AD, we will derive that AD also equals to A. AD equals to A. Then we did a construction. We extended side BC of triangle ABC by a straight line, and then from point A we drew perpendicular to the extended BC, so this angle is 90 degrees and this angle is also 90 degrees, and we defined the intersection point from the extended BC and from the perpendicular from point A and the extended BC as point E. Then we found out the value of this angle. We defined angle ACE as Y, and we found the value of this angle. First of all, we know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And then after we extended the straight line BC by a straight line, we got line segment BE that must be also a straight line. So we know that line segment BE is a straight line, and we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line BE at point C, that the sum of the angles must be equal to 180 degrees. That is to say 100 degrees plus the size of this angle, that is angle Y, must be equal to 180 degrees. I'll repeat again, 100 degrees plus angle Y must be equal to 180 degrees. We subtracted 100 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So angle Y equals to 80 degrees. Then we focused on the right triangle ADE. On the right triangle ADE, we know that triangle 80 degrees equals to AE over CE. On the right triangle ACE, we know that triangle 80 degrees equals to AE over CE, but AE equals to Y according to our definition, and EC also equals to X according to our definition. So we actually found out that triangle 80 degrees equals to Y over X. Then we multiplied this equation number 1 by X, and we found out that Y equals to X times triangle 80 degrees. Then we focus on the right triangle ADE. We defined the angle that we are looking for, that is to say angle ADC as theta. So in the right triangle ADE, you can see that easily from the drawing that sinus theta equals to AE over AD. I'll repeat again. In the right triangle, triangle ADE, sinus theta equals to AE over AD. But AE equals to Y according to our definition. And AD also equals to A according to what we have already found out. So in conclusion, we found out that sinus theta equals to Y over A. Here we multiply equation number 2 by A, and then we divide it by sinus theta. And we found out that A equals to Y over sinus theta. But according to equation number 1, Y equals to X times tangent 80 degrees. So we substitute Y in this equation by X tangent 80 degrees. And we found out that A actually equals to Y, that is X times and X tangent 80 degrees over sinus theta. So A equals to X tangent 80 degrees over sinus theta according to equation number 2, and Y equals to X tangent 80 degrees according to equation number 1. Then we focus on the right triangle, triangle ABE, big right triangle. From the drawing you can easily see that tangent 30 degrees equals to AE over BE. On the right triangle, triangle ABE, we know that tangent 30 degrees equals to AE over BE. But AE equals to Y, according to our definition. And BE equals to A plus X. So in conclusion, we found out that tangent 30 degrees equals to Y over A plus X. Then we substituted Y by X tangent 80 degrees. And here we substitute A by X tangent 80 degrees over sinus theta. And we got this expression. And we also have to add X. So X, we multiplied X by sinus theta, and then we divide it by sinus theta, so we change nothing. Here we moved sinus theta from the denominator to the numerator, and we got that tangent 30 degrees equals to X times tangent 80 degrees times sinus theta over X times tangent theta plus X sinus theta. Here we have X in the denominator and we have X in the numerator also, so X will get cancelled, and we actually we also know that tangent 30 degrees equals to 1 over square root of 3 units. So in conclusion, we found out that according to equation number 3, one over 3 equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we cross multiply this equation, equation number 3, and we found out that tangent 80 degrees plus sinus theta equals to square root of 3 times square root of 3 times tangent 80 degrees times sinus theta. Here we subtracted sinus theta from this equation, equation number 3, and we found out that tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Here we took sinus theta as a common factor. So we got the tangent 80 degrees equals to sinus theta. Sinus theta is a common factor of this expression. Inside the brackets we left with square root of 3 times tangent 80 degrees. And from sinus theta we left only with minus 1. Okay? And then we divided this equation, equation number 3 by square root of 3 tangent theta minus 1, and we found out that sinus theta equals to tangent 80 degrees over square root of 3 tangent 80 degrees minus 1. Okay, then we know that tangent 80 degrees equals to sinus 80 degrees over cosinus 80 degrees, so we substitute the tangent 80 degrees by sinus 80 degrees over cosine 80 degrees, and in the denominator we have square root of 3 times tangent theta and tangent 80 degrees, and tangent 80 degrees is sinus 80 degrees over cosine 80 degrees, and minus 1, we substituted minus 1 by minus cosine 80 degrees over cosine 80 degrees in order to have a common factor with this expression. Here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled, and we left only with sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. Here we multiplied the denominator by 2 and then we divide it by 2. and we got that sinus theta equals to sinus 80 degrees times 2 over 2. So here in the brackets we have square root of 3 over 2 times sinus 80 degrees, and we divided cosine 80 degrees by 2 after we multiplied by 2 here, so we change nothing. And then we got that sinus theta equals to sinus 80 degrees over 2 times here square root of 3 over 2 that we have here square root of 3 over 2. We substituted square root of 3 over 2 by cosine 30 degrees, and we substituted 1 over 2 by sine 30 degrees. Okay, so here is cosine 30 degrees, and here it is actually sine 30 degrees. And this expression, sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees, is very similar to the trigonometric identity that states that sine A times cosine B minus sine B times cosine A equals to sine A minus B. So we can substitute our expression by sine A minus B according to this trigonometric identity, when A equals to 80 degrees and B equals to 30 degrees. So we did it, and we got that sinus theta equals to sinus 80 degrees over 2 sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees, so in conclusion we got that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 sine 50 degrees, because 80 degrees minus 30 degrees is 50 degrees. Then we use the trigonometric identity that sine 2a equals to 2 sine a cosine a. According to this trigonometric identity, sinus 80 degrees equals to 2 sine 40 degrees times cosine 40 degrees. And in conclusion, we found out that sinus theta equals to 2 sine 40 degrees cosine 40 degrees over sine 50 degrees. According to the trigonometric identity that sine alpha equals to cosine 90 degrees minus alpha, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So we found out actually that sine 50 degrees equals to cosine 40 degrees. What does it mean? It means that we can substitute sine 50 degrees here in this equation number 3 by cosine 40 degrees, because they are equal to each other. So we did it, we substituted sinus 50 degrees by cosine 50, we substituted sinus 50 degrees by cosine 40 degrees, as you can see here, and we got that sine theta equals to 2 sine 40 degrees cosine 40 degrees over cosine 40 degrees. 2 over 2 is 1, so 2 will get cancelled. Cosine 40 degrees over cosine 40 degrees is 1, so cosine 40 degrees will also get cancelled, and we left only with sine theta that equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees. So the angle that we are looking for, that is actually angle ADC that equals to theta, equals to 40 degrees. So in both methods, we found out that the value of angle ADC is equal to 40 degrees. Okay, thank you very much.